All right, before we talk about the mean value theorem, I thought I'd give you just a little tiny bit of background on it. It was first stated by Joseph Lagrange, and if you keep studying calculus, you'll see that name again in Calc 3 and many other parts of mathematics. Joseph Lagrange lived between 1736 and 1813. He was a child prodigy. He was a professor by age 19, and yet, in spite of that, this is rare, he was known as a kind and quiet man, which I think is something worth mentioning. That's so often not the case with people who are child prodigies. The mean value theorem is the key behind much of the rest of the results that you'll see in the calculus sequence. You won't always hear it named. In these calc classes, we typically focus on how to do things and a lot less on why they're true. But if you care at all about the why they're true side of things, the mean value theorem is almost always sitting behind the scenes in about everything you're going to see the rest of Calc 1 and in Calc 2 and in Calc 3 as well. So what does it say? Well, let's let f be a function satisfying the following. 1, f is continuous on the closed-bounded interval AB. That's just an interval of the x-axis. I'm differentiable on the open interval AB. This kind of feels familiar, right? It feels like Rolle's theorem. The only thing I'm not saying, Rolle's theorem said f of a equals f of b, and I'm not requiring that for the mean value theorem. So if you have these two things, there exists a c in the open interval AB such that f prime of c is equal to f of b minus f of a all over b minus a. Now, what is this thing saying? It turns out it's not too hard to see it visually. So let me show you what's going on. First off, this fraction should feel very familiar to you. You should recognize that, or at least have some deja vu going on. Like, man, I've seen that before. This looks like the slope of a line, does it not? In fact, it is the slope of a line. It's the slope of a secant line through the points a f of a and b f of b. So let's draw. Here's a and here's b. And if I draw the line, I'm going to have a hard time on this iPad. Yeah, let's see if I can adjust it. There we go. If I draw the line through those 2 points, that's the secant line through those points. This line has slope exactly f of b minus f of a over b minus a. Okay, so we've got this side figured out. What's this side saying? This is just the slope of the tangent line. So what the mean value theorem is saying is if you have the right setup, then there's a point where the derivative, the slope of the tangent line at that point, is equal to the slope of the secant line. So let's hunt for it in this picture and see if we can find it. So if I look at the slope of the tangent line right there, these lines are not parallel, right? Two lines are parallel if and only if their slopes are equal. So we expect our tangent line to be parallel to our secant line. That's what it means to have the same slope. That line that I've drawn is obviously not the line that we're after. Let's try again. Maybe somewhere right in here. This one looks pretty good. Oops. That's pretty close. Maybe you would argue that we should fudge it a little bit left or right. That's fine. I can't get too precise by hand. But the point is, you can imagine there's a point where the tangent line is parallel to the secant line. That's actually all the mean value theorem really says, is if f is continuous on this closed interval and f is differentiable on the open interval, then there's a point at which the tangent line is parallel to the secant line. Let's play with it over here on this picture that I've drawn. So let's first off draw our secant line through the 2 endpoints. And now let's switch to yellow. And let's see, it looks to me like right in there somewhere. I'm just going to draw it, tangent, and see. Yeah, there it is. There's one. And it looks like we're going to have another one right in here somewhere where, yeah, something like that. So here there's actually 2 places. Is that allowed? Absolutely. This is just an existence theorem. It's not saying there's a unique point. It's saying there's at least 1 point. And here you can see there's actually 2. So I won't prove this. It's tempting. I'm not going to prove it for you, but I did want to show you how you prove it. And just to be very, very brief, you actually write down this new function h of x, and you set h of x equal to your old function, the one that you care about, f, minus f of a, minus this slope of the secant line times x minus a, and then you actually just use Rolle's theorem. So if you plug in, here, I can't help myself but saying one or two more words. You can check yourself, h of a equals h of b. Please check that. And now all of a sudden Rolle's theorem applies to h, and you'll find a point where h prime is 0, which gives you exactly what you want. So I won't go through the details, but I would highly encourage you, stop the video, play around a little bit, and see if you can see how this function h that I've written down will give you what we want for the mean value theorem. This function plus Rolle's theorem. So I'll stop this video here. In the next video, we'll do